Hi guys and girls on YouTube and welcome to my channel. So I've got this little Roberts radio. It's a reproduction, RD-60, a reproduction of the 1960s ones, I think. Now normally I'd stay away from anything like this because I've looked at these in the past before and you find the fault, you can't get the part, or there's no circuit diagram. But somebody's actually given me this, so before I throw it away I'm going to take a quick look at it. But I've had a look on the internet and I have actually managed to find a circuit diagram. So we're actually in with half a chance of fixing this. So I thought I'll just take a really quick look at it. Now I've got a bench power supply set up. I'll show you what the problem is. I've set it for 7.5 volt. If we press the on off button here, you see the display's lit up. We're drawing what, 110 milliamps at 7.5 volt. The display's lit up but there's no information in it. So basically we've just got the backlight lit. Now I would imagine that's probably some sort of a power fault, and looking on here there's an FET there. I presume that switches the power, but we've got some other, about, I don't know, 1, 2, 3, we seem to about 4 regulator ICs there. So it's definitely worth taking a look at. Now the first thing we've got to do with this is actually get it to bits. Now what you do with these is you take off this handle, and then under there's a screw on both sides, and that will remove all that board with the electronics on. I mean, I can see here these 3 cans there. I would presume they've got switching regulators. In fact, you can see an inductor there, and there's a capacitor there. We could actually measure the voltage on that. I'm not even sure if I can't see a dry joint right down there and a diode. But to look at that, we'll have to get it out to look at that properly. So let's get this bit out and have a quick look in it. Right, so I've got it on now and I'm measuring across that capacitor there, and we've got 7 volts, 7.07, so that's probably just power going in across there. Right, so the first thing we need to do is remove this handle, because there's a screw under there that takes that board out. Now removing this handle is relatively easy. If you look down there, there is a circlip. We've got to flick that circlip off. Now that's the easy bit. Getting that back on, well, that's a completely different matter, because if you look at that one, it's right down there, and if you look at the size of my finger, we're not going to be able to get a finger in there to put the circlip back on. We're going to have to very carefully use a thin pair of pliers. So getting the handle off is easy, getting it back on is a different matter. But let's take that off first. Right, so that's the 2 little circlips you remove, and then you just pull that out like that. And now with a big flat bladed screwdriver you can just undo that, like so. And then just do the other side as well. Next thing, you just pull off these knobs. These are only push fitted tight. We'll have to put the camera down for that one, that's even tighter. And then we need to undo that nut in there with the socket set. Right, so socket set out. Now the tuning one, that needs a 10mm, and the volume, that needs 11mm. So we just take that out of there. Right, so the next thing we need to do is undo these 3 screws here and take this plastic cover off. And undo these 2 screws next and pull that plug out so we can get this out of the way. Now this plastic piece is actually very tight in here, so what you might have to do is put a large flat blades of screwdriver down there and just twist that so it doesn't stick, because it's obviously been very tight, it's stuck to the side. Once that's moving about like that, we should be able to get this out now, and do the one on the other side as well. And then all of that lot will just pull out. Now you can see there where it's actually stuck to the side. That's what's made it very tight. But now we're ready to take this plastic cover off so we can get to the back of the board. There we go, and that now gives you access to both sides of the board. Now I would imagine it's a problem with a regulator or a shorted MLCC capacitor. Unfortunately, they seem to be covered up in cans. So we're going to have to take these off. I'm not sure which side. Or is that a lid there that comes off? I think that I might just pop that lid off so I can have a look first to see if we do need to desolder it or not. So I just flipped two of the covers up. That's handy. They didn't want this repairing. They're all full of some sort of wax. So now the capacitors are there. I can see an inductor. Let's hope that the chip is on the back side of the board under there. Otherwise it's going to be, we're going to have to melt all that wax to just look inside it. I presume it's done to stop the inductor whistling, but let's just hope that what we're looking for is under this side now. Right, so let's have a look what we've got here. We have a 5.3 volt regulator, a 1.2 volt regulator, a reset IC which just goes up to the reset pin on the LCD display, and another regulator there which appears to be 5.3 in and 3.3 out. So 1, 2, 3 regulators, a linear regulator and 2 switching regulators. So what I really need to do now is try and determine which of these cans to start taking off first. Yeah, I'll come back in a minute when I've had a go at that then. The first clue is L8, that inductor. I've traced that and that goes into the middle can. So that'll at least tell us what that middle can is. Well, that was a complete red herring, because L8 is just the supply, the DC supply coming in. So what we're going to have to do is take all 3 cans off. Actually, I got that totally wrong, didn't I? If L8 goes into that, then that must be the middle one there. That's L8, look, and it goes under there. So that must be this one here, which is marked IC11. But I think the easiest thing to do is just take all of these off, and then the viewers can see which ones are which chips under where. But we think IC11 will be in the middle. But they're still going to have to come off anyway to measure voltages, so let's do that next. Right, well that's the 3 cans off, and straight away I can see what the problem is. There's a little MLCC capacitor there that's obviously shorted out because it's all black. That must be the output because you've got the cap there. But if we look up here, the cap there's all black, and also it's taken out that 5-pin SOT23 regulator. So let's get a better angle. That's your shorted MLCC there, but your chip's burnt up. So I don't know whether this is going to be a viable repair or not, because I find that sometimes when you try and remove a chip that's burnt up, you can pull all the print off as well. But anyway, let me just stop the camera and have a closer look. But that's obviously where it started there. So we could mark this on the circuit diagram, couldn't we? Let's come back in a minute. Right, so the chip that's burnt up, the little 5-pin chip, is IC8. Right, so I've actually just downloaded the data sheet for this chip. It's an S8550AA. That's the pin out. And this just makes it a little bit easier to understand than trying to look at that small diagram, because I'm trying to work out whether there's a capacitor on the output that's burnt up or there's an inductor on the input that's burnt up. That's what I'm trying to figure out, what that is there, inductor or capacitor. But I'll come back in a minute when I've just studied this diagram. Right, that's the pin out diagram for it. That makes it easier. Right, so to make it a little bit easier to understand, so pin 1's the input, it comes through an inductor, it's decoupled by 2 capacitors, an MLCC and an electrolytic. This chip is totally burnt up. This inductor on the input is burnt up. What I thought was an MLCC is actually an inductor. That's burnt up, so it won't be any of these two short because the chip's burnt up, so the current's flowed through there to the chip and down to earth. So it looks like the only problem is the chip and the inductor. But like I say, once you start removing parts that are burnt, quite often I find the track will come up with them. So let's just take them off and see what it looks like without them. I don't know whether this is going to be repairable or not. Depends how burnt it is underneath. Let's have a look. Right, so that is the chip there. That is the inductor, and you can see how small they are compared to my finger. It's just that this is a small screwdriver, that's why they don't look that small. But anyway, I've cleaned it all up, and it would appear that most of the damage has occurred around the inductor. I've still got 5 pads on there I could solder onto. Most of the damage is there, so we might be in with a very slight chance of repairing this. You can see there 5 pads still intact, ready for a new chip. Right, okay, so I'm going to have to order a chip, so I'll put all these bits in a bag and we'll come back to it later on when the chip arrives. And what I like to do now is put all the notes I've made, diagrams I've printed off, screws, everything in little bags, and seal that all up in a big bag, and then just stick it on a shelf somewhere while you wait for the new chip, and then you're not wasting bench space leaving it all disassembled while you're waiting for the new part. So let's come back to it and see what happens. It's got 2 choices, it'll either work or it won't. Right, so we're back on this. The little chips arrived. I've ordered a couple of them just in case I get the problem again. Right, so that there is the new, I don't know if you can see on there, but it's 5 legs anyway. Let's get it fitted into the radio and see what happens, see if it cures the problem or it doesn't cure it. Right, so that's about as good as it gets. I've just changed that little inductor there that was faulty as well, but that had burnt up and actually damaged the board. That's the inductor there. You can see where the board's burnt, but I've managed to link it across with a bit of solder onto the inductor. I can't zoom in on this camera. Let me see if I've got like a cheap microscope that gives you a better picture. Just give me a second. Right, even that's not actually very good, but you can see the new chip there, and there's a little inductor, and you can see where I've joined it on to the track that's all burnt there. But I've tested it for continuity and that is absolutely fine. So let's plug it in now and see what happens. Right, so I'll just get this connected up to me vintage bench power supply, because my other power supply is in use now. I bought this when I was a kid, about 1978 and 1979 I bought this. from the shop where I worked, and it was £69.90, and that was an awful lot of money then. So I'll get it connected up. I'll just plug in these two connections on the back, and then we'll film it live on camera what happens, whether it works or it doesn't work. Right, so here we go. Switch it on here, and straight away I can see that it's drawing current, so we've got something wrong. In fact, if you look on that, it's lit up on the screen but with no backlight, because it's not actually on yet. It's not on till you press this. And power supply is clicking, so we do have some other problem, unfortunately, because when you turn it off the display's still lit, and we don't appear to have any sound either. Oops, it's falling off. So it's changing on there, but I'm not hearing no sound, and it don't switch off. Right, so what I found here is this line here, power enable high. When that toggles between high and low when I press the on and off button, and that operates this pin here of this chip, which switches on and off this chip, so there's no drive to that. Now I found here that the output is permanently, this pin here, number 4, toggles, so we know it's switching when you press the power button, but the output here is stuck on all the time. So that would infer either that FET is short, or there's some internal problem with this chip here. So what I need to do now is find that FET, which I'm assuming is going to be that one there, because that is the other chip. That's the chip we replaced, and that is the other chip, this one here. So let's just make a check of that FET first. And if you look at that there, I'm on the input, the output of the FET, and it is dead short. So I don't think for 1 minute I'll have one of them, but what I'm going to do is I'm going to take that out, and then we can check if this has drive when you switch the chip on and off, because if it's short circuit the gate, it might have taken that IC out as well. So what we need to do is remove that and then check we've got drive on that pin there. But what's that? FDN 358P. I don't think I've got one. I might have one. FDN 358P. Let's just have a quick look. No, unfortunately haven't got them, so might have to stop this video and order that part now. All this stock, and half the time you've never got the right part that you want. Right, so I've got the data sheet for that chip now. It's an XC6366B, a little chopper control IC. So that's what we've got, an external FET. We need to take that out, and we need to check or scope to make sure we've got a switching waveform on the gate, because that'll tell us if that IC is faulty or whether it's just that FET that's shorted out. So let's do that next. Right, so slightly bad news. I've just shorted the FET. I've taken the FET out and I've shorted it out with a bit of wire so we can see it's on. But when I check the drive here, there's no output from that little chopper controlled IC. Now I would expect that you'd see here a square wave drive even with that FET removed. So it's possibly, we know it's shorted, but it's possibly it's shorted to the gate as well, and it's put a high voltage on there and taking that IC out. I mean, this This job's getting more and more complicated. So we need that as a minimum, but I'm pretty certain we're going to need that as well. So I think what I'm going to have to do is I'm going to have to order up some more bits, and then we'll come back to this. Yeah, the little FET, I'll just put it in this plasticine stuff I got from the garage down the road so I can test it. It is actually short of source to drain, but there's considerable leakage into its gate as well. So there's every possibility of taking that chip out as well. So let's come back when we get some more parts ordered. Right, so another thought's just crossed my mind. I don't know why I didn't think of this before. So with that FET short there, where we should have 5.3 volt, because that's a step down switching IC. So where we should have 5.3 volt, if you trace the input to the FET, it goes straight up to the DC jack there. So I'm running on 7.5 volt. What hadn't crossed my mind is with that short, instead of having 5.3 volt there, we're going to have more like 7.5. So what I've done is I've drawn a line to see everything that 7.5 volt will have connected to. So it connects to that choke that's burnt up to the input of that IC. Now I don't think that'll be a problem, but if we follow it down here, it takes some other paths. It goes up to a chip there which is the line output driver, the line audio, and it also goes to there which appears to be an audio preamplifier, and one of the main loadings on the 5.3 volt rail is actually the audio amplifier chip. So what we need to do is we need to get a data sheet on that IC and a data sheet on that IC and see what the maximum supply voltage they will take before the chips are damaged, because I'm thinking now this is why we've got no sound, because either that's faulty or that's faulty. So what's that there? I'll tell you what, I'll pull up the data sheet and then you can see it better. That and that. In fact, here's another thing I hadn't noticed. The 5.3 volt rail also goes to the headphone amplifier chip, so we'll need data sheet on that and that chip. Right, so I've got the data sheets now, and this job is going from bad to worse. So this IC here, the NJM2100, the data sheet says the maximum single supply is 5 volt. Now that might not be a big deal because it actually goes through a resistor to limit the voltage, and there's another one there goes through a resistor. So they may or may not be faulty. The headphone amplifier, let's have a look at data sheet for that. The maximum supply on that, which is an LM4809, is 5 volt. Now once again, that goes through a resistor to limit the voltage, so that might be alright or it might be faulty. But what's a bigger concern is the 5.3 volt rail goes straight to the audio output with no limiting resistor. It goes to a little choke, so that could be damaged as well. But we can pick all this out with making some measurements with a scope. So what I'm going to have to do is I'm going to have to order that FET and that chip there. What is it? XC6366B. Going to have to order that and that FET. And the FET is an FDN 358P, and then once we get this supply rail back to 5.3, then I can scope the input and output of these amplifiers. Now that chip there, the audio amplifier, I've got that many bits of paper here, I don't know whether they're coming or going. I pressed the wrong button on my printer and printed off 43 sheets when I only wanted the first page. according to this it comes in 3 different packages: a BGA, VSON and a HSOP, and I don't know which one we've got, because they all have the same part number on. So I can't just see it in here, but if we look where the speaker wires go under there, they seem to go to this end can. Now there's obviously no audio output chip on there, so it must be underneath the can on the other side. So for now I'm going to order these 2 parts, and when we get that rail to 5.3 then we'll look for why there's no sound and come back to this job. Right, I'll see you in a bit then. This might take a few days to order these, so I'll get on with something else and come back. Right, so we're back onto the Roberts radio. The parts have arrived. Here's the plan. What I'm going to do is I'm going to change this switching IC here, and then I'm going to check pin 1, the gate output, with a scope, make sure it's switching. If that's all okay, I'll fit the FET next, and then we can measure the output rail. That's the 2 parts in there, so that's the next thing to fit in. I've just got to remove that little chopper control IC first. Right, so I've just got a little bit more light on the job. That there is the new 5-pin chopper control IC ready to be fitted, and you can see how small these are. In fact, what I've done is I've ordered more than one in case I lose one, and that's a good tip if you're doing anything surface mounted. Always order more than what you need, because chances are you'll lose one somewhere. But anyway, I've cleaned up the board, it's ready to go in. There, you've got 2 pins there and 3 there. And for refitting, I'm using this IF8300 no clean BGA flux, because originally this component, I don't know if you can see on there, where's it gone there? It was glued down originally, a little dab of glue there. Well, this flux is very sticky, so that'll hold it down while I solder it in. Right, so I've got the bench power supply connected. I've set 200 milliamp because we've no sound, if you remember, so we don't need a lot of current draw. But this chip doesn't seem to be switching without the FET connected. I thought it might do, or it might not do. There's a quick pulse on the drive, on the gate drive there, but I think because there's no feedback to pin 5, the IC switches off. So what we're going to do is put the FET in now and try it again, and then we'll know for definite. But it does seem like, I thought that might have switched without it, but it looks like it doesn't. Right, so that is the FET fitted. You can see it there. I've just soldered a ground wire on there for my scope. Let's just turn that off. We've got too many reflections from the bench light, but you can see, I'll zoom in. That's the 2 parts I've just fitted. Right, let's try scoping it now. And right, I've put the FET in, it doesn't work, and guess what? I've only gone and ordered the wrong one. I've ordered an FDN 357N, and we need FDN 358, and it doesn't work because one's an N channel and one's a P channel. So back to the drawing board. I'm going to have to place another order now. I'll come back to this again. Right, so we're back to the Roberts radio again. I've placed another order. That's another small order charge. Let's see if we've got the right one this time. Right, here we go. FDN 358P. Just double check that with a diagram. FDN 358P. This time we've got the right one. Let's put that in and see what happens. Right, here we go. Let's try again. Now I've got the right FET in. There's the camera in focus. Yeah, you can see it there. Let's turn it on. Right, and there we go. Right, let's just see if we can scope the drive coming out of that IC. It says on the data sheet it should be 300 kilohertz driving that FET. Well, it's obviously working because the radio's come on, but let's just scope that drive. I'm trying to hold the camera at the same time as do this. That's the gate there, or the gate output I should say. And there we go, 290 kilohertz. So that is absolutely perfect. Now the only thing we've got to do now is sort out the sound. And did I mention before that there's 3 different packages of sound IC? So what I'm going to do is I'm going to just scope out on here where the sound comes from and just check to the input of the audio amplifier. If we've got sound there, we'll need a new IC. Let's do that next. Right, so the driver for the audio amplifier is IC2, and that is the same driver chip that runs the line out, the audio line out, and it is same chip as IC1, which is an NJM2100M. So there's 2 of the same chips used in here. Now if we look on the board, none of these chips are labelled up. The only one that has a label is that one up there, IC3. These others, it don't tell you on the board which one they are. So considering these 2 chips the same, I would imagine it's that one and that one. So we need to check either one of them and make sure there's audio coming out of it. Yeah, in fact, if you look at that, we've got audio at pin 1 and that there's pin 7. We've got audio at pin 1 and pin 7 on both of these ICs here. So coming out of that, it goes through a blocking capacitor, a resistor, and straight into the audio output IC. So we're pretty certain that audio output IC is damaged. Now I can't find it on here, but the speaker wires go under this tin here, so we're going to have to take this off and have a look under here and see what package the chip's in, and then I'll have to get that ordered next. Right, come back in a minute. Right, actually, one thing I have just noticed before we get too involved in this IC, there is a mute line to it. There it says mute all. So if we just trace that, goes in that diode to the base of that transistor. Right, so the mute operates, pin 1 of that IC will either be high or low, because that transistor pulls it down to ground. So that'll be a high feed there, and then when that turns on, but when that transistor turns on, it pulls that to ground. So I'm just going to double check this before we look at this. So it's Q5. Right, well there's no Q5 on this side, so it's either under that can, or more than likely it's that transistor there in the back of the board. But I'll just, and because none of the parts here have any numbers on it, doesn't say Q2 or anything on the board, which is a bit of a pain, but I'm just going to identify that by the parts connected to it and check it with a diagram, make sure it is that first. Right, so okay, that little transistor there, the base goes to a cap which appears to go to earth, but more importantly it goes to a 1K resistor. So we check with a diagram, there is no 1k, there's a cap to ground there, but there's no 1k resistor. So either this diagram's wrong, or this transistor here is not the muting transistor. So what I've done is I've unsoldered that can. Let's look on the other side now, see what we've got. Right, well, still can't find that transistor, but according to the data sheet, the mute pin should toggle between 0 and 2. We just need to find on here which is on and which is off. I'll come back in a minute. Right, and here's the answer to that in the data sheet. Can be put into shutdown mode when pin 1 is logic low. So we've got to measure pin 1 now and make sure, what do we say it should be for high, about 2 volt. Just check that first then. Right, so there we're on pin 1 of the IC and we have 5.35 volts, not 2 as I imagine. 2 must have been the minimum. But anyway, so that should be active. We should have audio coming out now. So I'm just going to check the supply to that IC. This is something I didn't check, but I'm assuming it's right. That we've got a 5.3 volt on pin 6. If that's correct, we need a new IC. Right, so that's now on pin 6, and we have 5.4 volt. So he's got supply, he's not in shutdown, he's got audio going in. We need to change that little 8-pin IC now, the audio amplifier, to be class D audio amplifier, that. And probably, well, I'll have to see, might have to take them chokes off or this cover off. I'll have to have a look, see how easy it is to get in there. Right, so out of the different variants, that's the one we want there. 3mm square QFM package. Let's get one of them now. Right, so that's the new audio chip. Let's just get it out. And if you look underneath it, it's also got a heatsink connection to the ground, that pad there, so we're not going to be able to take that out with any soldering iron or any soldering bits. We're going to have to take that out with hot air, and it's going to have to be refitted with hot air, which is probably do that in the circuit actually. Right, let's get that in then, see what happens. In fact, to tell you what, it's not marked on the board which way round it goes, so I'm just going to have a look with a magnifier and make a mark on this board, because there's a little dot somewhere on this IC and we don't want to put it in the wrong way round. It's a bit of a pain on these boards, nothing's actually marked up. It doesn't say what diode 1, diode 2, TR1, TR2, nothing at all apart from these big capacitors seem to be marked up. Quite poor that really. Anyway, let's get a new chip in there and see what happens. Right, so that's it. I've just put the new chip in with hot air. Let's get this. You can see it down there. Now I have slightly melted the Evo stick on these two inductors. I might just pull that off. I'll just put that there so we don't melt them wires. But it's like kind of an Evo sticky. Well, it smells like Evo stick when it's burning. But I'll just scrape that off. But anyway, the chip's in. It's pin 1, which is there towards me, and that's why I've made a mark on there, so we don't get that the wrong way around. Let me just see if I can zoom in, give you a better view. Yeah, there we go. I mean, it might have been better to take this can off and take these coils out, but you can see the soldering's fine, the alignment's fine. just wants this scraping off now. We don't need it anyway, do we? Right, let us zoom out and we'll try it. Actually, before we try it, where I was going to take the can out and I've desoldered it, I'll just solder these back up because they might be important earth paths. And if you remember that amplifier I did not long ago, it didn't work with the back on. So just in case these are some sort of earthing path, I'm going to solder them up first and then we don't make any mistakes. Right, there we go. Scraped off the burnt glue, cleaned up the flux remover, soldered all them earthing points because I've had a bad experience with earthing points in the past, and all cleaned up. You've a job to tell now anything's been done to that. The only giveaway is the little bit of burnt track there I've had to repair. But apart from that, that's the other two bits I put in. Apart from that, that's looking good. Right, there we go. Screening can, clip back on. Let's see if it works now. Now the only thing in here is the reception is very, very bad, because I'm in a metal box here. Like all the outside of the building's clad with metal. I don't even get a mobile phone signal inside, so not an ideal test. But I'm just going to plug the aerial of this into the television aerial. I know that's not really very good, but at least it will pick up something if it works anyway. Right, so here we go. Power supply is set to 7.5 volts. I've got my temporary aerial on there. Let's just turn it over. Which one's the on? That one. Here we go. Here we go. 3, 2, 1. Yeah, and there you go. So as you can see, the reception's absolutely terrible, but we have sound. That's all that matters.
Anthem from Blur. Oh, congratulations to Andy, he's our winner. I think that's his first.
Right, so there's one last test we need to do, because if you remember early on in the video, the headphone amplifier, audio amplifier chip is fed from the same supply, but it's actually fed through a limiting resistor. So I don't think that chip will be faulty, but what we need to do is just check it by plugging a pair of headphones in, and that should mute the internal speaker, and then if we get sound through the headphones, we know that chip's alright. Let's do that next. Right, rather than the pair of headphones, I've got this little tiny pair of speakers. Here we go.
From the compact 2008, the stylish 3008, to the roomy new 5008.
Well, that's muted the sound, and we've got sound. We've got sound through that little pair of speakers, so we don't need to worry about the headphone amplifier IC. That's absolutely fine. The only thing we've got to do now is put all this back together, which I'm absolutely dreading, because I don't know how I'm going to get my finger down here to get one of them circlips on. But let's get it all reassembled now it's working. Right, so all we need to do first is put them screening cans on. I've got them here. Let's just turn them over. You can see the one with the burn mark in. That was the one that went there. Not that I don't think it matters if you get them in any order, but we'll put that back on where it was. There we go, that's that done. Just got to get all this back into its case now. Right, so that's it. We're nearly back together, but the last piece of the jigsaw is the part I've been dreading, is these circlips. Now, this one's alright because there's plenty of room, look, to move your hand about. But how do you get one down there. I can't even get my finger in, so I don't know how on earth I'm going to get that clip on. But anyway, we'll have a go. You can see the space in there where you've got to clip it on to the end of this thing. Oh, no, it's not the end of that, is it? It's the end of the handle it clips onto. That's it, the handle goes through there and then it just clips on to that very end there. But let's have a go and see if we can do it. Right, so I've just about managed to get that circlip on. I just held it with a pair of tweezers and then push it on with a screwdriver. But there we go, it's down there and it's on. So there we go, guys and girls, that's the Roberts RD-60. I've got it all back together. I'll just give you one little demo. Oh, here we go for the final time. So what can I say about this, the Roberts RD-60? This has just been one big learning curve. I've spent far more time on this than it's even worth. Even though the parts are readily available, they're very cheap, but they're all surface mounted. It's very time consuming. Just to give you an idea, the audio output chip, it's a 3mm square QFN. It's got 8 pins on, and that's the audio output chip next to a penny. That gives you an idea how small it is. So it's a very intricate job, very time consuming. I think at one time Roberts had you could send these back to Roberts and it was only about £45 to have it repaired at Roberts. I probably spent well more than that in time, but the good thing about it is I've learnt quite a lot along the way. I've also got parts in stock to do another one, and this has all been made possible by the fact that Roberts have published a circuit diagram on the internet. If there was no circuit diagram, there'd be no chance of repairing this, because the parts are just so small, and it's difficult to interpret the numbers on them, especially these switching regulator and the FET. There'd be no chance of even finding them if we hadn't got a circuit diagram. But there you go, one big learning curve. Hopefully if I get another one in, I can do it a lot quicker next time. Alright, guys and girls, many thanks for watching. I hope you've enjoyed the video, and I'll catch you in the next one then. Goodbye.